You seen yesterday?
Or in Flint. I'm probably
Looking fancy, for real fancy. All right. Okay. All right.
You're doing something fancy,
Okay. All right. Hey, real quick. My goal is to do 2 or 3 problems today. Kind of give you a range of kind of difficulty on problems. Start with kind of something easy, kind of work on my way to the more challenging problems, and kind of show you kind of what you're going to need to be able to do. Okay. Now today is one single Google question of the day. It's not a Google form. It's a single question. You'll type in your answer. You submit it back to me. I grade it. It's a participation grade today. So, okay. So I know it will seem difficult, but it should be a thing where you just I want you to try it today. Okay. All right. So let's discuss. So the section we're in the second section of chapter 3, which is on quotient rule. Okay, so we're in section 3.2, which is unit 4, but we're doing quotient rule now, and we have to learn. Okay, we have to learn the basics of quotient rule. Okay, so what I want to talk about today is how do we find a second derivative for a fraction? It's something that we saw the other day. We could change the problem up. But I want to talk about a problem where maybe we do something like this. There's a couple different ways of doing it. But let's say my function looks something like this. Let's go with 5x to the third power plus, let's go with 2x squared. And we're going to divide everything by a 3x. I'll start with an easier one. Okay? What I consider easier.
Yeah.
Okay? All right. So we're going to find the second derivative.
Wait, and our homework is product rule?
Yeah, it was all product rule.
Oh,
You're supposed to change everything. This is now quotient rule, so we're gonna leave everything a fraction. I'm not gonna drag the 3x up and make it a negative power. I'm not gonna do that. We're not gonna do that today on this stuff, this next section. We're gonna learn how to do everything using quotients from now on. So to do this problem, the quotient rule, if you don't remember the rule or the formula for it, so how this works, whatever your function is, let's call this a of x is the top, b of x is the bottom, right? So when you take the derivative of it, when you take the first derivative of a ratio, a fraction, it's derivative of the top times the bottom minus sign the derivative of the bottom times the top all over the bottom square.
That's the first group.
That's first derivative. If we do it again, then we have to do everything you saw up there and do it one more time.
Even the bottom?
Even the bottom.
So the four?
So it'll be, we'll square it again and it'll become a 4. So that way the bottom is actually kind of easy because you're just squaring the bottom again. So you'll just get a 4. The top is the nightmare where you have to take the derivative and all that. So. All right. All right. So, moving on. All right. So let's do the first derivative here. All right. Okay. First derivative of this kind of thing. Now we have to take the derivative of the top, which is what?
15x squared.
15x squared plus 4x. Okay. There's the derivative of the top times the bottom, which is 3x, right? So that's the derivative of the top times the bottom. So that's what you're seeing here, derivative of the top times the bottom. Now we have to put a minus sign. And now we're going to do the derivative of the bottom times the top. All over the bottom squared.
Yeah, are you insulting gay people, Braden?
Okay. So now, here's the idea. If we have to do the second derivative, this is the part that some people were trying the other day. I would most definitely simplify this thing before I start. I want to get the item on the top to be a single, like, polynomial before I attempt to go further, before I attempt to take the second derivative and do the monster that's sitting up there that currently is. Question.
But in the product rule, you want to put the thing from the bottom on the top, right?
Yeah, you always want to move that bottom up.
Okay, good. I thought
Yeah,
the whole
no,
time.
no. You always want to move the bottom up, then you start the problem,
Gonna run
right?
myself.
Yeah, so, all right, so on this one, I'm gonna clean it up a little bit. So this is still the first derivative. I'm not really changing anything yet. I'm not going to a different color. I'm still in the first derivative. I'm just gonna clean up the top. So like FOIL, distribute, however you want to say it. Question.
No, I was feeling my collarbone.
All right. So 3x times 15x squared. This turns out to be 45x cubed. 3x times 4x is 12x squared. So that's the first time when I distribute the 3x over it. In the back, I'm going to distribute a -3. This is the part that most people will mess up on. It's this distributing because most people forget the negative sign. So -3 times the 5 is -15x squared, or sorry, x cubed. And then -3 times that is -6x squared. That is the numerator for your fraction. And the bottom, if I square the bottom, you actually have two parentheses, you square it, and it turns out to be 9x squared.
Oh crap, you distribute? Wait, no, it's a different rule.
Okay, now I know I can combine like terms, I can combine the x cubes, I can combine the x squares. I understand that. You could do that, that's fine, I don't care. If you wanna simplify that even one more step, this ends up being 30x cubes and 6x squares. 9x squared. All right, so I've simplified this thing
Are
down.
we taking the second derivative
What was that?
or not?
What?
Are we taking the second?
Yeah, we are going to do the second derivative now. Now, this is why I would choose to simplify, is because now, if you didn't hear Morgan, she asked, are we doing the second derivative? Yeah. We're going to do the second derivative, so that's whatever we ended up with on the first derivative, we start and do it again. So this ends up being on the bottom, so for the second derivative, it's going to end up being the 9x squared, and we're going to square that again. Now, if you didn't simplify the bottom like I did, maybe you didn't write the 9x squared, maybe you left it like this earlier. Maybe you left it like 3x with the square on the outside. You're going to square it, it'll just be 3x to the 4th. So that's the same thing that you're looking at here. It's 3x all to the 4th power, because you squared it. So, okay, does that make sense? I don't mind if you didn't simplify the bottom. Now, the top, though, we have to take the derivative of the top times the bottom, and then we subtract the derivative of the bottom times the top. And that's where I'd like to simplify things, because if I didn't simplify the bottom, I would have had to do chain rule. And I don't want to do chain rule in the middle of this thing. So again, derivative of the top of this thing, that ends up being 90x squared plus 12x. That's derivative of the top, times the bottom, minus the derivative of the bottom, times the top. And you can leave it right here. That's the second derivative. I don't need to simplify it any further. The only thing that possibly could change is maybe you didn't have this written down here. Maybe you still had, 3x to the 4th power instead of this thing. That's fine. It's the same thing. Question?
Can you grow your beard out anymore?
I can't. It looks terrible. I gotta clean it up anyway.
Really?
Yeah.
Oh, bring your stash back.
What?
Bring your mustache back. Please.
I have to go bald if
How
it.
did
No,
you
it's
get
cool.
18x?
Okay. All right.
How did you get 18x?
That's the derivative of the bottom. Okay. All right. Questions with that? Okay. This is what we're doing today. We are trying to find the second derivative. It would get a little more challenging depending on like what items I provide you. Like I consider this one easier. The reason why this problem I consider easier is that we just had a monomial on the bottom, not a binomial, and it wasn't really complicated looking. This thing can get super ugly really quick, especially if that bottom is kind of a nasty polynomial. Like this could be a really devilishly hard problem if the bottom is a really wicked polynomial or radical, because then it gets really ugly and we can't simplify and everything. I'm not going to probably do that to you for this next assignment, because this stuff, like as you're saying, it takes this will take paper. Like I thought the last assignment I gave you 1 or 2 challenge questions. This stuff could be wicked. I remember doing Calc 1 problems for this stuff, and it took me multiple days to get it done. And that was when I was in high school like you guys were. And I was doing it, at home and at work when I was working after basketball and all that. So it took days to do that stuff. So yeah,
Why did you have to do that?
because it was a college credit. I took it as college credit my senior year.
Oh, we can't do the college credit?
No.
That's ridiculous.
So we're still gonna have to take this in college?
No, you could potentially test out.
In college.
All right, okay, all right, let's do one more. Does everyone have the formula though? Everyone understands that? Okay, I'm gonna do one more, that's all I wanna do. One more. I wanna make the bottom maybe a little more challenging, maybe not super difficult, because the one I provided you on Google is like this one. It looks really close to that, by the way. So, all right.
Wait, don't erase that. Yeah, don't you dare.
Trying to get the formula written down.
Yeah, I didn't write it at the beginning.
Yeah. Let's do one more and then I'm done for the day and you guys can answer your Google question of the day. Okay, we good? Okay, we good?
Yeah, he's good.
All right, moving on. All right, let's do the second one, last problem of the day. So, same exact thing. We're gonna do the second derivative now. Second derivative. Let's kind of make something a little more complicated now. Let's go with 3x squared plus 2x squared all over, let's go with 4x squared plus 2. So now, this is a more difficult problem. If you choose to, you could FOIL the top first. Like take the two parentheses, FOIL it. It's up to you guys. It will make the problem easier later to do it if you FOIL it now. If you choose to FOIL it later, fine and dandy, it doesn't really matter. It's kind of up to you guys. What do you guys want to do? You want me to FOIL or leave it?
Leave it.
Leave it. We're leaving it. All right, moving on. All right, so let's do the first derivative here. And I'm going to put the first derivative over here. Okay, first derivative, and then we'll do the second derivative over there. Okay, derivative of the top. So it's a chain rule. Drop the 2. Drop the 2 out front. Then we take the times the derivative of the inside, because again, I subtracted 1 off the power. The derivative of the inside is 6x plus 2. That's just the derivative of the top, by the way. It was a chain rule. Drop the power, leave it alone, then take it times the derivative of the inside. Okay, that's derivative of the top times the bottom. Right? Times the bottom. Then we have to subtract the derivative of the bottom, which is 8x, times the top. All over the bottom squared.
You should have followed the word.
Oh yeah, that's why I said you should. Okay, all right. So what you're looking at here, this is the first derivative. First, not second. Okay, stop hitting it. So put your mask on right here. All right. Okay. All right, we're ready to go.
If you're gonna smack and put your mask on, is
All right.
How many times has he said it? How many times has he said it?
You missed a spot.
Missed a couple spots.
It's only Jared. Yeah.
OCD is going to go off. I can't get it all. All right, moving on. Before I focus on it. All right, I don't want to look at it. All right.
Just close your eyes.
It looks good for
Okay, I need to simplify the top a little bit. I don't want to leave this look the way that it is. The reason being I don't want to leave it look like that. If I have to take the derivative of the top again, oh man, that thing would be super difficult. I'd have product rule and product rule and product rule. I don't want to do that. I'm going to simplify this. I have to distribute, like FOIL, and then distribute again. There's going to be a lot here, so cleaning this up here before I take the second derivative, let's distribute the 2 over this parenthesis. Again, it only goes over the first parenthesis, not all of them. So that turns out to be 6x squared plus 4x, okay? And then I'm going to take it times this, and then times this. Okay, and in the back, oh man, I have to foil those two out. It would have been a lot easier if I foiled this earlier. Okay, so we have that. I'll have to foil that here in a second. And the bottom, we could foil that too. I guess it'd make it a lot easier to look at. Okay, so we're gonna do some foiling here to make sure I can take the derivative of this thing. All right, so the bottom. Now again, I'm not taking the derivative yet. This is just cleaning this thing up so that I can take the derivative later. It's just kind of a process of cleaning stuff up. So I'm gonna foil this mess together here and write that down. Then once I'm done with that, then I have to do it again. This is gonna turn out to be 36x to the third plus 12x squared plus 24x squared plus 8x. 8x? All right. And I still have to take that times the 4x squared plus 2. And we have the minus sign, we have the 8x. Foiling the back two parentheses together, that's 9x to the fourth plus 6x to the third plus 6x to the third plus 4x squared. All over, and now foiling the bottom, 16x to the fourth plus 8x squared plus 8x squared plus 4. Yikes. Ooh. I haven't even got to the second derivative yet. I'm just cleaning this stuff up. And I'm making any mistakes. 12, 24, and 8. The 4x, yes. 9, 6, 6, and the 4, yep. And the bottom, 16, 8, 8, and 4, yep. Okay.
Nice.
Okay.
This is so interesting.
It's so dumb because it's not like hard math.
Yeah,
it's
just
just
time
so
consuming, yeah.
much.
Yeah. All right. Now, still multiplying this out now. This is multiplying out the entire, the top part here, and then multiplying this back here. This is where I could potentially lose some people. All right, so I'm taking this.
What are you talking about?
So, all right, 36 times the 4. It's a 4, carry a 2. That's 144. X to the 5th plus 72x
Wait,
to
what
the
did you do in
3rd.
your head there?
What?
Tell me how you did
Oh
that.
my gosh.
Okay, you can figure it out later.
6 times 4, carry the 2.
Whoa, guys.
So 6 times 4, carry the 2 because it was 24, and then 3 times 4 and add the 2 to it.
Keep going before you lose.
Moving on. So 24 times
Like a
that,
pause button.
48x to the 4th plus 24x squared. That is 6 carry a 1, 96x to the 4th plus 48x squared plus 32x to the 3rd plus 16x minus 72x to the 5th minus 48x to the 4th
Whoa.
minus 48x to the 4th
You're gonna need another weapon.
minus 32x to the 3rd, all over 16x to the 4th plus 16x squared plus 4. Ooh.
That's a hate crime.
Did I get those all right?
You're asking the wrong
That was a
thing.
lot.
Wrong kind of thing.
Let's see.
Did you or did
Let's see, did I get anything wrong?
You're supposed to be the smart one here.
I
Wait,
can't add
what's
my head.
48 plus 96?
I can't do that in my head. I
forgot.
can't
You
add.
can't do that in your head, but you
Are you
can.
kidding me?
I got
Subtract
multiply
4
it.
from 48. 144.
Yeah, I can multiply and divide, I can't, and start mine. Alright,
I wish I had that
Just do
problem.
48 times 3.
alright. And
Or
finishing it.
Oh, it's basically 100. Add that, subtract the difference.
Okay, alright.
I'll just do it.
Alright.
Bothers me.
Alright. X, I need to simplify that. Alright, how many X to the 5th do I have?
Or if that's the assignment today, just give me this.
Now, it was, the assignment you see today, the Google question of the day looked like the first one I did.
It's 72.
So, ends up being 72x to the 5th. X to the 4th, 48, 96, minus 48, minus 48. I got 48 x to the fourths.
You'll tell him.
Should I mess up something?
What? Are you done with it already?
Why did I put
No, I'm just looking through it, I'm like, yeah, that makes
144s?
sense.
The
It's all just a lot of the same.
Oh,
thing.
144 x to the fifth and 144
I'm
x
already
to
done
the
with the
fourth.
Google Classroom question. though.
Where?
Oh, wait. Thank you. Oh, you just have it separated, I think.
Stop it.
All right, anyway. X to the fourth, I should have 48 x to the fourths. X cubes,
Okay.
72 plus 32 minus
30.
32. So I'm back to 72. 72 x to the thirds. X squares, 24, 48. That's it. 72.
Yeah, a lot of these just cancel out.
X squares and X's.
16.
16,
I think.
and that'd be it. All right, so 16, X. All right, and there's no constants, right? No. And this is all over the 16 x to the fourth plus 16 x squared plus 4. Okay, so what you're looking at here, first derivative.
Did you simplify that?
Oh my god.
What?
That's the first.
Never mind.
Okay,
First.
now, yeah, I know.
I can't remember.
All right,
Yeah.
okay, so I've simplified it down, taking the second derivative. Now, the good news is for second derivative, I don't need to simplify.
The second derivative.
So, again, I kind of warned you, the minute they make a nasty polynomial on the bottom, it just exponentially grows this thing really
Will you
fast.
show us like really fast, like if what would happen if we did FOIL it after this?
If you did,
Like at the beginning, since we decided not to?
it would have been really short. It'd probably been about
Well, can you
half,
show us
half
when
of
we're
it.
done?
I don't want to do it again. I'll just trust you can try it on your own if you need to.
You trust us?
Oh yeah.
No.
All right. Okay. You can foil and you can do it. All right. So, top derivative. So derivative of the top. Let's see. It's a 0. Carry 1. 350.
I'm so done.
No. 360. 360. X to the fourth plus. Oh God. What is that? 48. It's a 2. Carry a 3.
You sign up for this
192.
one.
X to the third.
Yep.
6, 21, 216,
Yep.
x squared plus 4, 444, x plus 16. That's the derivative of the top
What the?
times the bottom. 16, x to the fourth.
I don't have the room.
16, x squared plus 4 minus the derivative of the bottom.
Slow down, buddy. Slow down.
64, x to the third.
Dude. Bud, shut up.
Plus
16 times 1.
32,
I said
x
shut
to
up.
the third. No, x. All right, and then we take that times the top.
No.
All over the bottom
Don't
square.
cop out, Ward. I want to see you write it out.
Write it out.
Write it
You're making
sideways.
us type it.
Write it sideways.
You're making us
Yeah, you
write
had
it
to
out. Write it out.
You
One
make us
question,
type
I just put,
stuff.
I'm not typing this.
Squirt.
Not my answer.
Well, good thing that I didn't give you one this hard. So, all right, there you go.
We're supposed to be grateful.
That's it?
Oh yeah. So that's your second derivative. So now,
Okay, simplify it.
simplify. I'm not simplify. We don't need to. All right. So I don't want to. I don't want to multiply again. All right. Okay. As you can see, second derivatives get messy. Now, in normal polynomials, second derivatives get smaller. Right? They do. They get smaller and smaller. But when you do radicals like fractions, and you do second, third, fourth derivatives, they get bigger and
That makes
bigger
no
and
sense.
bigger and bigger. And so it's the idea of a concept that when you multiply fractions, the fraction gets larger. Top and bottom number gets larger because you're multiplying straight across. That's kind of what's happening here. And so that's why these kind of exponentially grow really quick. Obviously, I'm not going to be assigning something like that every single day. I'm going to be picking shorter ones that you could potentially do shortcuts on.
Oh, really?
So those are the things we need to learn. And that's what we're going to look at tomorrow. We're going to learn some basic shortcuts tomorrow that you could potentially use that we've learned in pre-calc that'll make your problems easier. Okay? So that's what we're going to look at tomorrow. Okay? All right, so be ready to go. So Google question of the day went live. You have to type in your second derivative and it should be a simpler problem like the first one we did.
It is.
The first
Why?
problem was
I don't want to
no.
hear it. You can do that problem if you want.
I know you.
Do it again. It's simplifying.
I enjoy it. You psychopath.
Yeah,
Turn off.
okay.
the
Okay.